So section 10.2, it's called test for independence or chi-square test. Whether you have an older calculator or a newer one, all of you should have the test. It's like that when you look on the calculator. Okay, what is this chi-square test? No, that's just section 10.2. So a student is asking me what is this? So we did 10.1, we did 10.4. I'm going back to 10.2. So we'll just have 10.2 and 10.3. And we'll be done. And as I said, guys, for chapter 11, I'm going to make it give you some extra credit assignment, last chance for extra credit assignment that you can turn in when you take, on the day you take your final exam. I'll give you details about it later. So let me go back to section 10.2. Okay, this test, it's a chi-square test, just like in section 10.1, it's a chi-square test. And this test is used to determine whether there is a relationship between two variables that are stated or represented in a table like a contingency table, which I'm going to show you an example right away. So how do you state the null and the alternative hypothesis for this test? It's going to be very standard, just like 10.1. In 10.2, in HO, you say the variables are not related or are independent of each other. And then in the alternative hypothesis, you say that the variables are related or dependent of each other. So you're going to see that it's very easy to state the null and the alternative, just like in section 10.1. In section 10.1, you say the distribution is as claimed, and in HA, you say the distribution is not as claimed. You notice in section 10.4, you say mu1 equals mu2 equals mu3 for the null, and you say at least one of the means is different from the others for the alternative. And in 10.2, it's going to be HO, the variables are independent of each other. And for HA, that's going to be the variables are dependent or are related to each other. The condition of the tests. You know, in section 10.1, there were expected values and observed values. And it's the same thing. You have observed values and expected value. You have to find expected values. And each expected values must be at least one. This is one condition of the test. And no more than 20% of all expected frequencies should be less than 5. So these are the two conditions of the test. But if we ask you to perform this test, guys, you can assume that the conditions are met. You don't have to worry about them. So what I'm going to do, guys, I'm going to take you to an example right away and show you how to perform this test. And I'm going to use the calculator right away for this test. So it's going to be example 3 right here. Let me see. Okay. If you have a hard time with the internet, guys, I'm recording this, so I'll provide the recording later today. You notice that I don't provide it right away. Sometimes it takes hours to render the video and upload it to YouTube because they're large size files. They're not small size files. Okay. Here's the typical examples of section 10.2, guys. A medical researcher is interested in determining if there is a relationship between adults over 50 who exercise regularly and low, moderate, and high blood pressure. A random sample of 236 adults over 50 is selected, and the results are given below. Test the claim that regular exercise and low, moderate, and high blood pressure are independent. Okay. So what did we say for HO and HA, guys? We say HO, the variables are independent. So we're going to write the variables are blood pressure and exercising. So regular exercise. And I'm just going to copy this. And low, moderate, high blood pressure are independent. This is where the claim is. HA, guys, will always be regular. You can put the variables, but since he named the variables, you should know you should not just use the generic word variable. Just list what the variables are. It's blood pressure and exercise. Regular exercise and blood and low, moderate blood pressure are dependent or related. This is the opposite. It has to be the opposite. So, and the claim in HO, because he says so, he says check that they are independent. Any questions so far, guys? So this is how you state the null and the alternative hypothesis. The next step is to find the test statistic, which is chi-square equals, this is exactly the same formula as we used in section 10.1, but I'm going to show you how to use the calculator right away to find chi-square and to find the expected values. No, HO is always independent. HA, the variables are dependent. So that's what I put there. And now the claim is test the claim. He says test the claim that the variables are independent. So I have no choice but to put the claim there because he wants us to check that they have nothing to do with each other. Do you agree, guys, that exercising and blood pressure for people over age 50 are not dependent? They don't depend on each other. A lot of people think that regular exercises will affect, just blood pressure. But here he wants us to check that they have nothing to do with each other. This is what I meant earlier by contingency table, guys. You've seen that in chapter 3 when we did probability. Like if you ask me what does 35 represent, it means there are 35 people over age 50 who exercise regularly and have low blood pressure. There are 62 people who exercise regularly and then have moderate blood pressure and so on and so forth. And if you remember, just we did totals before. So I'm going to do them here because you're going to need them in a little bit, but not if you're using technology. So that's 90, 122. And then you get 86, 114. And then you can do totals from this side as well. That's 56, guys. That's 127. And this is 53. So if someone asks you what does 53 represent here, you just tell them it's the number of people with higher blood pressure. Whether they exercise or don't exercise, that's a total. If someone asks what's 114 represent, it's a number of adults over age 50 who don't exercise. What's 122? It's a number of adults who exercise. And if you do the grand total, it's going to be 236. All right. Any questions, guys? All right. Now, in order to use this formula, guys, you need the observed values, which these are the observed values. You have 35, you have 62, you have 25, 21, 65, 28. Each observed values have an expected value that I'm going to show you how to use the calculator to find the expected values, but I'm just going to give you a hint on how you can do those expected values by hand as well. It's a lot of work, just to do them by hand. In section 10.1, to find the expected value, you just take the percent and multiply by the total for each category. But it doesn't work this way for section 10.2. So let me show you guys how to find the expected values here. Like for the value 35, to find the expected values, this is what you should do. To find the expected value for the number 35, you take the total of the row that 35 belongs to, which is 122. And then you take the total of the columns that 35 belongs to, which is 56. You multiply the 56 by 122, and then you divide by the grand total. So it will be 56 times 122 divided by 236. To find, for example, the expected value of the number 62, this is what you do, guys. You take the total of the row that 62 belongs to, which is 122, total of the column that 62 belongs to, which is 127, multiply and divide by the grand total, and so on and so forth. How many times you have to do this? 1, 2, 3, 4, 5, 6. Now, rather than doing it this way, we're going to have the calculator do the whole thing. I'd like you to pay attention. This is something new that you're going to learn about the calculator. And how can you enter values that appear in a table and make them look like they are in the table on the calculator? I couldn't do L1 and L2 because I don't have the values listed separately, in columns here. Like the 35 belongs to this row and belongs to a column. So I cannot just split them up and put them in columns together. So I have to put them just like in a table. And there is a way on the calculator, guys, and how to enter those values in the table. So I'd like you to pay attention and see how I'm going to do this for this section, for section 10.2. So step number 2, we need the test statistic. And then step number 3 is the p-value. And I'm going to demonstrate how to do this using the calculator. So let me bring the calculator back, guys. There's the calculator. Okay. So I'm going to go very slow, guys, because once you pick it up once, you should be able to do it anytime. So you need to put those values in a table format that the calculator can understand. And here is how you do that. So you press second, and then X inverse, which is matrix. Matrix, guys, means like a table. Matrix is a table that has rows and columns. Now, can someone tell me how many rows of data do we have here and how many columns of data? Can you guys tell me? How many rows?
3.
Oh, you don't count the headings. The headings don't count because they don't have data. These are just names. So would you agree it should be 2? 2 columns, 2 rows of data right here, guys. 35, 62, 25 is 1 row, and 21, 65, 28 is a second row. And how many columns of data now? Don't count the headings. Don't count the titles. Let me see what we have.
3.
3, I agree. Let's see what the chat says. 3, exactly, guys. Don't you ignore this and you ignore that. So you have column 1, column 2, column 3, row 1, row 2. Okay. Let me go back now to the calculator and show you what we're going to do. You're going to like that because the calculator. So you press second and X inverse, and you go to edit and press enter and select. This is an array of numbers. This is a table. Select the number of rows and the number of columns, guys. So the number of rows is 2, and then go to 3, and then 3. And watch, guys, just enter the values. You see what appears on the screen, something like the table that you have in the question. It's just exactly like it. So just fill in the numbers. So type 35 here, type 62, type 25, and type 21, type 65, and type 28. And quit. You're done. So second and quit. And now go to stat tests. The calculator doesn't need the expected value. It's just going to compute them by itself. Scroll up. You see chi-square test, guys, is letter C. This is for section 10.2. If you take in the note, that's for section 10.2. The one after it, it's for 10.1, the goodness of fit test. You should not mix up between the two because this says GOF, goodness of fit test. Okay. You don't do nothing here, guys. It's telling you the observed values, you put them in A. Yeah, I put them in matrix A. The calculator is going to put the expected value in matrix B for you, and you just hit calculate. Okay, that's chi-square, which is 3. Let me move this on the side. 3.47. And what I'm interested in is the p-value. The p-value is 0.1761. I don't need the calculator for now, guys. Just I'll have it retire for now. And let's continue. P-value is more than alpha. Fail to reject HO. Conclusion. The claim is in HO, guys. So there is not enough evidence at the 0.01 level of significance to reject the claim. We use the word reject because the claim is in HO. That blood pressure low, moderate, high, and regular exercise are independent. You know, this question is telling you whether you exercise or not. It doesn't impact. That's what we could not reject the claim. So probably we have to pick a different samples because a lot of people believe that regular exercise does impact, blood pressure, but maybe not for people over age 50. So remember this, it says people over age 50. So there is not enough evidence to reject the claim. We cannot reject the claim that the blood pressure and regular exercise are independent. Okay, so this is what we call independence test, to test whether two variables are related or not related. The variables in our question was whether you exercise or don't exercise. This is one variable. The other variable, whether your blood pressure is low, moderate, or high, this is the second variable. And this is what we call an independence test, guys. Now, let me show you the expected values here. If you are to find the expected value for 35, this is what I said we have to do, guys. You take the row total, which is 122, multiply by 56, and divide by the grand total. So let me bring the calculator back. If you are to compute this, guys, let's see. I'm going to show you that the calculator has done the work already, but just show you. 122 times 56 divided by 236. So you get 28.9. Okay, let me show you now where the expected, remember the expected values were stored in a matrix called B. Here's how you get them. Go to second, X inverse. You see now, you notice B is 2 by 3. It was created for this test. Just press enter and press enter again. You see the values, guys? They're right there. 28.9 corresponds to 35. 65.65 corresponds to 62. You want to see the next one? Let me just do in one decimal place. So I'm going to just do math, fraction, not fraction. No, I'm just going to go to mode and just do one decimal here, or probably two decimals. Second and quit, and let me do the matrix one more time. So second, x inverse, sorry, second, x inverse, that's matrix. Let me take it to 2.3, and you're gonna see, guys, enter. See, it's more clear now. 28.95, 65.6, 27.40 corresponds to 25, 27.05 corresponds to 21. Next one is 65, and the last one, 25.60, is from 28. Look, for 28, if you want to do it, you have to take 114, multiply by 53, and divide by 236. Let me do it and see if I get the same answer. If I don't get the same answer, I'm in trouble. It means I'm giving you false information here. Should match. See, 25.60. You get the same answer. So the calculator will save you all that work by just displaying the expected values in a matrix called B. Okay, we're going to do another exercise. Recording. A food services manager for a baseball park wants to know if there is a relationship between gender and the preferred condiment on a hot dog. So whether male or female have different preferences when it comes, just to eating hot dogs. The following table summarizes the results. Test the hypothesis with a significance level of 10%. So, you see, 15 means 15 male prefer ketchup. 19 here, guys, means that 19 female prefer mustard. So does it matter whether the person is male or female when it comes to choosing, the topping, the condiment on a hot dog? We need to check if there is a relationship. That's a relationship in taste when it comes to eating hot dogs. So here you say condiment and gender are independent. That's what I said always. The variables are independent. And then this is HO. HA, guys, will be a gender and condiment on a hot dog are related or dependent. Now I'd like you to tell me, where is the claim here? Is it an HO or HA? A food service manager wants to know if there is a relationship between gender and the preferred condiment. So what do you think the claim is, guys?
An HA.
Yeah, I agree. Here you can put the word preferred. Just copy the language. Okay. And now, guys, we're going to put this in matrix A. And let's decide how many rows and how many columns. Before you do it, you guys agree with me there should be 2 rows, male and female. Don't count the total. Total is not count as a row. I just did the total here if you do the work by hand. So rows is 2. And can you tell me, guys, how many columns are there?
3.
3. Totals don't count as a column. This is you created. That was created by us. So it's just 3. I mean, there are 3 condiments, guys. How could it be 4? Ketchup, mustard, and relish. So it's a 3. Okay, so now let me just go back to the calculator and do this together. See, it's amazing how the calculator can do that with the matrix. So you go second and X inverse, you go to edit, and nice, I have 2 by 3 already. So I don't need to change anything, just change the values. Okay, 15, 23, 10. Next one, guys, 25, 19, 8. That's it. And just so I don't forget, I'm gonna go to my mode and change it back to float. So it will give me as many decimal places as possible. So if you do that, just change it back. Okay, guys, you're ready for the tests. The name of the test is chi-square. Oops, I skipped. Oh, too far. There you go. Don't do anything here. If you put your observed values in A, you don't need to do any changes at all. Just hit calculate, or you can draw if you want to draw the distribution. It's a skewed distribution. It's a chi-square distribution. There you go. Positive distribution, as you can see, guys. So chi-square is what? 2.948, 3 decimal places for chi-square, and the p-value is 0.229. So tests, chi-square test, and then chi-square is 2.948, p-value 0.229. I'm done with the calculator. But before I continue, let me show you guys the, if you will like to see the expected values, they're done for you. You press second, X inverse, scroll to B. If A was 3 by 3, you will see B is 3 by 3. It will be generated for you. And press enter. And look, these are all the expected values. 19.2 corresponds to 15. 20.16 correspond to 23, and so on and so forth. So p-value is more than alpha.
I didn't get that p-value.
Oh, you got a different number?
I got 0.815.
Let me check. Let me check if I made a mistake in the matrix, which I don't think so, if you guys were paying attention.
I got the same p-value as you.
Oh, you got the same values? So probably you made a mistake in the matrix itself. Let me just check. So we enter 15, 23, 10, 25, 19, 8. So I'm very positive that you did not have those numbers exactly. That's the matrix is correct here. So it's more than alpha. Fail to reject HO. And there is not enough evidence at the 10% level of significance to support the claim that, or to conclude, you can use the word conclude, to conclude that there is a relationship between gender and preferred condiment on a hot dog. Yeah, I didn't think that there was a relationship that women prefer different condiments than men. They're just probably everybody eats it the same. So that's why we could not support the claim that there is a relationship between the two. Any questions about this one? All right. So in order to use StatCrunch to do the independence test, you have to recreate the same table in the StatCrunch. So we have male, female. Then right here, you have ketchup. And then you have mustard. I just select the variables, guys, and type. You just change its name. And you have relish. And just put the numbers. So I have 15. I have 23. And then 10. Don't put the total. StatCrunch knows how to compute all of this. You don't need to provide. Only provide the raw data, the actual data that's given. The next one, we have 25, 19, and 8. 25, 19, and 8. I'm typing in. Here we go. And now, let me show you how to perform the test. You go to Stat, Tables, Contingency, with Summary. I got the summary of the data. Okay. Select the column, it's variable 1. Select, so where this is the column male or female. Now select the raw labels. I have ketchup, you have to select the 3 of them, and this is how you select them. You press the control and just select them. Or raw labels is just, sorry, the variable 1, we're still, we're still male and female. Column labels right here. Oh, sorry. Let me just go back. I'll just do it one more time. I got confused there between columns. So you go Stat, Tables, Contingency, with Summary. Okay, columns. I have ketchup, I have mustard, and I have relish. I have to select those 3. Sorry, I just press the Control key and select them. Row labels, just the first one, which is variable 1. That's it. And now let's run the test. Now, do you need to use StatCrunch here? Probably not. You always can use the calculator, which is probably faster, because you have to recreate the table right here and just hit compute, guys. And same answer, look. You got the value 2.947 and the p-value. And now, if you want to see the expected values, let me show you that StatCrunch can display the expected values as well. Watch. Go to Tables, Contingency, Tables, with Summary, Columns. The columns, I have 3 columns, so let me select them again. Ketchup. Press the Control key to select the 3 together. Row label is variable 1. Okay, here, hypothesis test. Okay, And we need the expected values. Okay, the expected count, I'm gonna select it here. And now it's gonna display it. Watch, guys. And now if I go hit compute, what happened? Share screen one more time. Okay. Watch. Hit compute. And look, guys, you got the expected, you got the table, just the matrix B, expected values. 19.2, which is the expected value for 15, 20.6, which is the expected value of 23, and so on and so forth. And you get the test statistic, 2.948, and the p-value, which is 0.229. And so to perform an analysis of variance test ANOVA using static crunch, first of all, the data should be displayed in static crunch. If you have 3 columns, it will be 3, 4 columns, 4, and so on and so forth. And here's how you run the test, guys. You go to stat, ANOVA, one way, select the columns, press the control key, guys, in order to select all 3 of them. And I think that's it. I'm just gonna shorten it a little bit so you can see compute here. Hit compute. And look, guys. Let me show you what we're looking for. Only those 2 values. This F and the P value. Don't worry about the rest. This is all calculation done to obtain F and P. So F, the test statistic F is 2.131, and the P value is 0.1583, which is more than alpha, fail to reject HO, and the same procedures that you learned. So this is how we use static crunch here.